Hello everyone. For this tutorial video, I would like to show how to make the paddle move appropriately so that it does not change the vertical position or go off the screen. In particular, if we were to look in the sensing functions, we would see that there is a mouse X variable, so we can update according to the mouse X position and not the mouse X and mouse Y position at the same time, and test if it works. Sadly, it did not, and this is because the Scratch engine is strange and picky about the goto function versus the goto x and y function. They do two separate things and check for two separate things. In particular, the goto function as it is now requires both an x and y component, which we have not specified, so it does nothing. But if we use goto x and y, we can use mouse x and the x component and keep the y position and the y component, like this. And now it works as it should. Now that we have fixed the paddle, we can make the ball move as it should. And this is where a little bit of the more tricky math comes in. But if you were to stop and diagram out how the line would work in your mind or on a piece of paper, that should make it a little more easier to understand. In particular, we would do when green flag clicked as usual, and then have it on a forever loop move 10 steps forward, like this, but also have it bounce if it's on the edge. However, this script only works for the edge. It will not detect the paddle for you, so you would have to do the math manually. So you would use a separate script to check when it touches the paddle. And have it turn 180 degrees. So we will check to see if this works. And unfortunately, we cannot get it to hit the paddle, as it is moving left and right and not going down toward the paddle. So we would fix this by making it point 180 degrees or toward the bottom as given by the graphic. And unfortunately, it passes right through the paddle. Because of the way the script is written, i.e. that it moves 10 steps forward permanently even when it touches the paddle. So we would fix this using an if-else statement instead, so that it will only move 10 steps if it does not touch the paddle. Sadly, it still does not work as intended. And this is because of the strange way the collision boxes work if the object is too thin. So you would have to make the object more thick for the collision to work appropriately. Like this. However, even with the collision box, it still does not work as intended. And this is because the way it is scripted does not work as intended. In particular, we notice the problem is that because it turns 180 degrees as soon as it hits the paddle, it moves straight back toward the paddle, and so goes through as if the paddle did not exist. And we can also see that turning 180 degrees, if we were to imagine it or graph it out, does not accurately simulate bouncing. Because of the fact that if, for example, you approach the wall while moving northwest, you would not exit the wall southeast, but rather southwest, which 180 degrees does not explain. But we can see, if we imagine it, that northwest could be considered 180 minus northeast. So instead of turning 180 degrees relative to the degree we have, we would instead point in the direction of 180 minus a degree. And we should see too that 180 minus southwest should be southeast. And we now implement the function like this. A solution we could implement so that it does not move straight back toward the paddle as soon as it hits it is that we could have a sort of timer that should wait 1 second after you hit the paddle. Although if we implemented it in this manner, we would see that we would cause problems, because it would stop all the rest of the code from executing, so the ball would just stop randomly. So you would have to use a more subtle timer. So we would do this by adding a timer on the paddle sprite instead. And checking if the paddle touches the ball instead of the ball touching the paddle. And then broadcasting that it hit the ball. We next wanted to reset the timer, so that way it counts down from the ground up every time it hits the ball, which is important for a functional timer. We next make the script more complicated by checking if the timer has passed a specific amount before we broadcast right away. Or in this case, we should say to check if it is less than a specific number, as we want it to be within the time frame constrained. So that way, the broadcast stops and the ball stops bouncing after the broadcast. Like so. We also want to make sure to reset the timer at the very beginning, so that we do not have any extra seconds from previous games. With the timer in place and the broadcast in place, we can update the ball script accordingly, so that instead of checking if it touches the paddle, it will wait for the specific broadcast instead. Like so. And this is because we do not put the reset timer in the appropriate spot. Namely, that it should reset the timer as soon as it hits the ball. So I was instead checking if the timer was less than 1 before resetting it, which would have been impossible as the timer started counting down as soon as you started the game. So we try again. And it works this time. And it also reflects exactly like how we want, without bouncing off the paddle multiple times. However, the direction is only in the obvious case of north versus south, so we should test it with more complicated angles to make sure it gives the reflection we want. So we would go back to the ball script and make it point in a more arbitrary angle that is not the 4 cardinal ones, like 115, and see if it still works. And indeed, it does. Now that we have figured out how to make the basics of the ball interacting with the paddle, we can move on to making other elements of the game, starting with the bricks you break in the next tutorial. Don't forget to subscribe if you found this video informative, and make sure to see other tutorial videos, and follow me on either Facebook or Twitter for more content.